Confidence intervals, a simple explanation. This is a typical college-level final exam confidence interval question. A researcher wishes to test whether the mean of a normally distributed population with population standard deviation, 12.4, is significantly different from 23.8 at the 5% significance level. She observes a sample mean of 27.01 based upon 8 observations. Part A, estimate the population mean with a 95% confidence interval, and Part B is to use the 95% confidence interval to test her hypothesis. So the first thing we have to do here is convert these words into mathematical symbols. So when we see normally distributed population, we're going to write something like random variable x is normal. I'll just write norm for normal. And we have some population mean, which we'll call mu. And we also have the fact that the population standard deviation is equal to 12.4. So I got this right here. And then it says is significantly different from 23.8. So that means we have hypotheses here. So let's write the null hypothesis down. The null hypothesis is that mu is equal to, so if we want to test whether the population mean is significantly different from 23.8, that means the null hypothesis is that the population mean equals 23.8 against the alternative hypothesis that the population mean is different than 23.8. So we got all that from these words so far. And then it says at the 5% significance level. So since we're doing this at the 5% significance level, we are going to write down alpha equals 5%. And it's always a good idea when you're doing a question that you might want partial credit from if you mess up, put the alpha somewhat close to the hypotheses so your professor knows that you know this significance level deals with this hypothesis test. Then it says she observes a sample mean of 27.01. So we write x bar equals 27.01. And then it says based upon 8 observations. So we write n equals 8. So that's really the first step, is just converting this word problem into symbols. Now, part A asks you to estimate the population mean with a 95% confidence interval. So the formula for the confidence interval for the mean when the standard deviation is known is given by x bar plus or minus z sub alpha over 2 sigma sub x bar. Now, we already saw that the sample mean was observed to be 27.01. And we know that we want the 95% confidence interval. So I'm going to draw you a little drawing. If we're having a 95% confidence interval, 95% of the area is inside of this bell curve. So that means there's 2.5% of the area in the right tail and 2.5% of the area in the left tail. This is z sub 0.025, but it's negative because it's in the left tail. And this is z sub 0.025, and it's positive because it's in the right tail. Now, these are z-scores. They're also percentiles. Now, Some books will just give it to you straight away in a table, in a Z sub alpha table, just like this. And here we see 0.025 is the area in the right tail. So this z-score is 1.96. So we have plus or minus 1.96. And we saw that the standard deviation is known to be 12.4. So this is going to be 12.4 divided by the square root of the sample size, which it says based upon 8 observations. So this is the square root of 8. Now you might be saying, well, where did this divided by the square root of 8 comes from? That comes from the formula that sigma sub x bar is equal to sigma over the square root of n. Now this is called the standard error of the mean, sometimes abbreviated SEM. This is the standard deviation of an individual observation, which is also called the population standard deviation. I'll write STD for standard deviation. In this case, STD means standard deviation. So this is the formula for the standard error of the mean. And that's what this is. This is the standard error of the mean. So now, I really don't have that much to do, really. I'll just take my calculator out here. We're going to go 27.01 minus 1.96 times 12.4 divided by square root of 8 equals, and we get 18. Now I'm going to round this 1 off to a 2. 18.42. And that's called the lower bound of the confidence interval. Sometimes it's just called the LB for lower bound. And then the next thing we want to do is we want to do the plus. And on this nice little calculator, this Casio FX300 MS solar powered, I can just move this little scroll bar, and this little minus I'm just replacing with the plus. And now when I hit the equals button, I get the same thing without having to type it in again. So I get 35.60. And this is called the upper bound of the confidence interval. Some people just call it a UB. And this is the answer to part A. Right? Part A says estimate the population mean with a 95% confidence interval. So we just did this. This is the answer to part A. So I'll put a little check mark here, because that's the answer to part A. And now we have to do part B. So part B says, use the confidence interval to test her hypothesis. So she wants to know if the population mean is significantly different from 23.8. So recall that our null hypothesis is that the population mean is equal to 23.8 against the alternative hypothesis that the mean is different than 23.8. And different than is the same thing as not equal to. All right, so how do we do this? Well, it's a really simple thing. You draw a little number line, and you put the lower bound in. That's 18.42. And you put the upper bound in. That's 35.60. And then we want to see if this confidence interval captures the hypothesized mean of 23.8. And this 23.8 is about here. Right, that's your 23.8. So there are two good ways to write the final answer that your instructor is probably looking for. So one way to write it is, since the confidence interval captures the hypothesized mean of 23.8, the appropriate decision is to fail to reject the null hypothesis. And that's one perfectly fine way of writing the answer. A simpler way to write the answer is to simply say the population mean is not significantly different than 23.8. And that's really, in my opinion, this is the way I'd go. You might say something like at the 5% significance level. You could stick that in. And that's, good too. The population mean is not significantly different than 23.8 at the 5% significance level. So that's the answer to your test question.